972 Part A. That equation up there in the corner will come in useful in a second, but right now let me focus in on the problem itself. Assuming air is breathed at an average rate of 4.65 liters per minute at 25 degrees Celsius, 735 millimeters of mercury, and that the concentration of carbon dioxide in the expelled air is 3.4% by volume, how many grams of carbon dioxide are produced in 18 hours? All right, a couple general observations. First of all, they've given us a rate here, and rates are always a conversion factor. It's equivalent. It's equating liters, 4.65 liters, to 1 minute. And we're never going to start a problem with a rate or with a conversion factor. They've also given us a temperature. Once again, they've been evil, and they've given it to us in degrees Celsius. I'm going to convert it to Kelvin right away. They've also given us a pressure, 735 millimeters of mercury. And I don't want to be bothered with it later on, so I'm going to go ahead and I'm going to convert that pressure right away into ATM. 760 millimeters of mercury in 1 ATM. So that gives me a pressure of 0.9671 ATM. So now I've got a pressure. Let me try to keep my screen here together, so I'm going to recopy my pressure I just calculated. So I've got a pressure of 0.9671 ATM. According to that little bubble there, what is the concentration if the expelled air is 3.5% by volume? So they're telling me that I've got 3.4 liters of carbon dioxide for every 100 liters of air I have, because that's how percents work, right? Percents are parts per 100. So that's another conversion factor. They're wanting to know grams of carbon dioxide, and they've given me a time of 18 hours. Well, if I'm needing grams of carbon dioxide, the only way I know how to get grams in chemistry is to get them from moles. So they're really asking me for the number of moles of carbon dioxide. And I know whenever I'm dealing with gas laws and moles, it's going to involve using PivNert. So if I look at what PivNert is, PivNert, PV equals nRT. Well, right now I've got a pressure, 0.9671 ATM. I've got a temperature, 298 Kelvin. I'm wanting to solve for a number of moles. I know my gas constant, 0.0821 liters ATM moles Kelvin. The only thing I'm missing in order to use PivNert is I need a volume from somewhere. And that volume is going to come in through a little bit of a cutesy maneuver here. They've given us time. Other than being huge Hootie and the Blowfish fans, why in the world are they talking about time? They're talking about time because they want us to get our volume of carbon dioxide from that time. And we're just going to treat it kind of like we were back in that first chapter. I've got 18 hours. I don't know anything about hours, except that 1 hour is 60 minutes. Do I know a relationship between minutes and volume? Yeah, right there. So I know that I have 4.65 liters of air per 1 minute. Wow, that's like a really sloppy 4. Much better. Now I'm not wanting air. I need to get rid of air. Well, and that's where my percent comes in. Because I know that I have 100, for every 100 liters of air I have, or 100 parts of air I have 3.4 liters or parts of carbon dioxide. So I'm going to multiply everything on top, divide through by everything on the bottom. So I've got 18 times 60 times 4.65 times 3.4 divided by 100. And that gives me 170.748 liters of carbon dioxide. All right, I just wrote my calculator number down here. They're being really stingy with their sig figs. There are really actually only 2 sig figs here. So now I have a liters, or a volume, that I can use in a PivNert and solve for my number of moles. So that's what I'm going to do. I'm going to go back to my PivNert now. 0.967 ATM times 170.748 liters equals the number of moles of carbon dioxide times 0.0821, and I'm going to admit the units on my gas constant because I'm running out of screen. 298 Kelvin. So that gives me 0.967 ATM times 170.748 liters divided by 0.0821 divided by 298 Kelvin is carbon dioxide. So times 0.967 divided by 0.0821 divided by 298 gives me my number of moles of carbon dioxide as 6.748 moles. And now they want grams of carbon dioxide in the problem. So now it's just a cutesy finishing step involving my periodic chart. I've got 6.748 moles of carbon dioxide. I'm going to my periodic table and I'm calculating the molar mass of carbon dioxide. And that's going to be 12.011 plus 2 times 15.9994 equals 44.0098. That came from the periodic table, right? Sorry, I felt like there should be dramatic music. Came from the periodic table. So just multiply that. Your calculator is going to give you 296 6.978. Now, we established that there's really only 2 sig figs all the way back here. So if we're really wanting to be technical, it should be 300 grams of carbon dioxide, as in 3.0 times 10 to the second grams of carbon dioxide. But if memory serves me, I think the grad student here may have been sloppy on their sig figs. Let me do a quick check for you. Let me actually do the answer here. And see what they take. Yeah, they want the 300 grams, so the grad student's not that bad this time. That's it. Beep.